Good morning, all students. In our previous lecture, we have discussed about what is soil. Okay, what is geological cycle. Now, in this lecture, we are discuss about geological cycle in detail. Okay, going for the next lecture. Now, what are the contents of today's presentation? As we have already studied about introduction of geological cycle. Okay, now physical weathering, that is a part of erosion. There are two types of erosion. One is physical weathering and one is chemical weathering. We are going to discuss about this in today's lecture. What are the factors which are we need to consider for physical weathering? Okay. Next one is processes which are involved in chemical weathering, transportation of soils and phase diagram. Okay. Now, as we have seen this in our previous lectures, basically soil is formed by geological cycle. Okay, so there are four stages of geological cycle. One was erosion, second was transportation, third was deposition, and fourth one was upheaval. Now, uh, basically soil is formed by either due to mechanical disintegration or chemical decomposition. Okay, now this mechanical disintegration is known as physical weathering. Okay, there are the this figure is shows the all four stages of geological cycle. As you can see in figure, basically first one is mountains. Okay, from the mountains this soil is uh, due to erosion, it is going to the downward side with agencies like wind, water and gravity. Sometimes there is also ice which is in colder regions available, and ice is also acts as an agency uh, to disintegrate the rocks. Okay, so this is a one part of erosion. After erosion of soil, you can see in figure that due to erosion soil is from top of the mountain, it is going to the downward. Okay, from that place it is going to transported it with all these agencies like again with wind, water or ice or due to gravity. After the transportation, this soil is also going to downward side or maybe some of upper layer, and that is known as decomposition. After decomposition soil is going to the upheaval side. Okay, now discussing this in detail. Erosion. Okay, what do you mean by erosion? Basically erosion is a one type of, you can say that disintegration of rocks. Okay, now which type of these rocks are? These rocks are available on the parent rock, and these parent rocks are available at the mountains. Okay, so these big rocks, these big parent rocks are disintegrated into parts by some agencies. Okay, and there are other factors which we need to consider about this. Okay, so that process is known as erosion. Okay, due to erosion, our soil is disintegrated, sorry, rocks are disintegrated into parts. Okay, now there are two types of erosion. One is physical erosion, or it is also known as mechanical decomposition, and the second one is chemical weathering. Okay, now, what do you mean by physical weathering? Physical weathering, or also it is known as mechanical weathering. I have already said this. In this process, what is going to be happen? First of all, the big rocks are disintegrated into small pieces or small fragments due to some factors. Okay, these factors are, we will discuss about this in next slide. Basically, the process in which these rocks are disintegrated into smaller parts or smaller fragments is known as physical weathering. Okay, which factors are those? Basically first one is temperature changes, second one is wedging action of ice, third one is spreading roots of plants, and fourth one is abrasion. Okay, out of these four, temperature changes and wedging action of ice are mostly influencing factors. Okay, abrasion is a influencing factor but not as compared to temperature changes and wedging actions. Okay, now going to discuss about this in detail. What is going to be happen in these factors? First of all, temperature changes. What will happen here? Different particles or different soil minerals have a different coefficient of expansion, and this coefficient of expansion is thermal coefficient of expansion. Okay, so different minerals have different values of coefficient of expansion, and due to this coefficient, when temperature is changes, all materials have different values of coefficient of expansion. And due to expansion and contraction, as we all know that these particles are facing some expansion and some contraction, and all the materials or all the minerals have a different value of expansion and contraction. So due to this difference and due to temperature changes, what will happen, material will face some type of stress, okay, and this stress is comes in a rocks, okay, and due to this extra stresses which is caused due to expansion and contraction, a material or our mineral or our parent rock get disintegrated, okay. So this is the way how erosion is uh, going to be further going to be ahead, okay. Second one is wedging action. Now these actions, wedging actions of ice is comes in places where cold atmosphere or environment is available, sometimes of mountains, okay. In India that is available in Himalayan regions, but after Himalayan regions, if we are going to the South India or in western parts of India, wedging action of ice is influence of wedging action of ice for erosion is not as too much as considered for Himalayan regions, okay. So what is happening here, in colder atmosphere what will happen, water is held in the pores. Now what is pore? Pore is actually a blank space. Blank space means there is a some air which is present between two particles, okay. So that is known as pore, okay. So water is held in a pore, okay, and cracks of rocks get frozen. So if there is any crack between a rock or between some pores, what will happen, due to the cold atmosphere that cracks will be get frozen, okay. And due to this frozen crack, what will happen, a volume of ice is more, okay. If we already we know that ice is a higher volume as compared to the water. So due to this higher volume, the weight of the ice will be higher, okay. So what will happen, these cracks or due to this frozen cracks, expansion of mineral will happen, okay. And due to wedging action, stresses are developed and disintegration of rocks will occur. Third one is spreading of roots of a plant. Already we know that on the mountains regions or on that places, trees can grow on the root. Trees can grow on in the cracks. Okay, and these cracks are causes stresses on that rock, and due to this, disintegration of rocks will happen. Fourth one is abrasion. Now abrasion is a due to air sorry, due to wind, water and glaciers, okay. And these glaciers are moving from one place to other place, okay, and it will cause scouring or abrasion of soil or abrasion of rocks, okay. Now second one, that is a second type of weathering is chemical weathering. Now, chemical weathering is what? There is chemical alteration in chemical properties, okay, of a minerals, and new compounds are formed. If we are comparing a physical weathering with chemical weathering, there is one thing which we need to see is, you can see that there is no changes in its properties, okay. There is no change is going to be happen in properties of a soil due to physical weathering, but this will not happen in chemical weathering. Due to chemical weathering, new compounds are going to be formed. So this is a basic difference between chemical weathering and physical weathering. In physical weathering there is no change in its properties, but in chemical weathering there is a chance of a new compound will be formed, okay. So this process is known as chemical weathering. In this process, chemicals are chemical alteration is going to be happen, okay. And this chemical alteration is uh, either due to some gases available in atmosphere, okay. So following are the five process of chemical weathering. First one is hydration, second one is oxidation, third one is carbonation, fourth one is solution, and fifth one is hydrolysis. Going to be discuss about this in next slide. Hydration. Okay, now as name indicates, hydration means water. Okay, due to water. So in this process water is combined with the minerals. Okay, water is, which is present in atmosphere, or which is present in lakes, which is present in rivers, as we know that from the mountains rocks is, from the mountains water is flowing in downward direction from the upper layer to the downward layer. Okay, so in that places, what will water do? Water will combine with this uh, rock particles, and these rock particles, what will happen? It will result in a new compound. Okay, it will make a new formation of a new compound. Okay, and uh, this chemical reaction will result in change of a volume. Okay, second one is carbonation. Again, name indicates carbonation means there is a some presence of a carbon dioxide which is already available in our atmosphere. So in this process, carbon dioxide from atmosphere combines with water. Okay, now CO2, that is carbon dioxide, and water will make a new compound that is known as carbonic acid, and this carbonic acid will react with rocks. Okay, so CO2 plus H2O, that will make carbonic acid, and this carbonic acid is going to be processed with, or going to be react with rocks, and it will cause the decomposition of rocks. Okay, third one is oxidation. In this process, oxygen which is available in atmosphere will react with rocks. Fourth one is solution. Now in this process, soluble minerals or soluble materials which are already, which can easily soluble with water, like calcium carbonate, are dissolved. Okay, and it will wash it out by rocks when rainfall is coming. When rain is coming, this dissolved minerals which have already reacted due to water, and these are soluble in water. So as already these are soluble in water, what will happen? Due to its solubility, it will wash it out with uh, rainfall. Okay, and due to this rainfall, they are also going to carry some sand or some broken rocks its with it flow. Okay, so this will cause a new solution. Fifth one is hydrolysis. As in this process water gets dissolved, or sorry, water is going to be disassociated in two parts. Okay, one is hydrogen and second one is hydroxyl ion. Hydrogen, that is always hydrogen is positive ion, and hydroxyl is OH minus, that is minus cation. Okay, and hydrogen, what will hydrogen do? Hydrogen will replace all the metallic ions which are present in soil particles. Suppose there is sometimes there is some portion which is magnesium content is available in our rocks, calcium content is available in our rocks. So this this hydrogen ion will react with this these minerals, and decomposition of rock will happen. Now transportation of soil. There are already four agencies which are responsible for the transportation of soil from one place to other place. We have already discussed about this in our previous lecture. Okay, these four agencies are water, wind, and due to gravity, and fourth one is ice. Now transportation of soils with water. Now what is happening? Water is running from source of water, that is either it is starting from the main source which is situated on the top of mountains or from these places. Okay, and after that, this running water, due to its flowing, it has some it has some capacity to carry some volume of a soil with this water. Okay, and this soil is either transported in the form of suspended particles. Now suspended particles means particles which are already uh, carried by water. Okay, and either by, it is going to flow by suspended particles, or either by rolling and sliding of bottom of a stream. Now what is happening when water is flowing from one place to other place. It will make some portion of a stream at one place, other place, okay. And in these streams, okay, in these streams, what soil particles are due to sliding and rolling, it will settle down at the bottom, okay. And when water will passing through this, once water is passing through passed out from these places, from these streams, or from these points, the soil will try to remain at that place, okay. Now what as we know that there are two types of soil: coarser particles and finer particles. What will coarser particles do? Coarser particles will try to settle down at that place due to decrease in velocity of water, and the finer particles are carried out by to the downstream and deposited when velocity will reduce, okay. Second one, transportation of soil by wind. Now, wind has a capacity that it can erode, it can transport, and it can deposit fine grained soils. Okay, as we know that due to water, coarse grain particles are settled down at one place, and water is going to carry with its velocity, and it's moving water finer particles. Now, as finer particles, these finer particles can be transported with wind also, okay. So fine grained soils can be transported by wind in desert areas, okay, where the velocity, or where the wind velocity is higher, okay. Silts and clays blown with wind are deposited, okay. As silts and clays have a size of a particle is very low as compared to sand and gravels. So these particles will, what will do, these particles are deposited in loose condition, and this loose condition soil is known as loess, okay. It has a low velocity and high compressibility. Transportation of soil by glaciers. Now, as I have already said, due to glaciers or due to cold atmosphere, this is a process which can be happen in only and only colder regions, okay. Now, glaciers are large deposits of ice formed due to compaction of snow. Once at one place snow is settling down, again snow is settling down. So what is happening, due to settling down of snow, there is a one layer or other layers are snow are going to be compact on each other, okay. And this type of snows are make glaciers, okay. As glacier is moving from one place to other place, it can carry different sizes of soils, okay. Soil get mixed with these glaciers and transported it away from its original position, okay. Transportation of soil by gravity. Now, due to gravity, soil particles are transported for the shorter distance, okay. Movement of material is limited in this process as compared to wind, as compared to water, and as compared to glaciers, okay. Due to there is a limited movement, there is no appreciable change in its material, okay. Now next our topic is three-phase diagram, okay. What is three-phase diagram? Basically, soil has a three soil is a solid particles, water and air, okay. Now these soil particles are creates voids. Either in these voids, either it can carry air or it can carry water, okay. So from that point of view, it is said that soil contains three phases. Basically, soil is a three phase. One is a solid state, one is water which is present in soil, and third one is air, okay, air voids. Now, these three constitute are joined with each other and make a complex material. If you want to analysis a soil cross section of a soil, we need to discuss about all these uh, phases or all these materials which are available in soil. So we need to discuss about solids in different way, water in different way, and air what is present in water, air what is present in soil section. We need to discuss about this in a different way, okay. So a diagram which shows all three phases in one diagram, that is all three materials in one diagram, that is known as three phase diagram, okay. You can see in this image, as solid particles have a higher specific gravity, so it will settle down in the bottom. Water has a specific gravity which is less than solids and higher than air, so it will settle in this middle portion, that is water. And in top level there is air present. Air is a less specific gravity as compared to solids and water, so air will come at the top. In middle there is a water, and at the bottom it will be solid particles, and these solid particles are particles of soils. Now in your GTU there is a three types of diagrams are given in your syllabus. One is three phase diagram, second one is two phase diagram for fully saturated soil, and two phase diagram for fully dry soil. Okay, first of all we are going to discuss about the equation of three phase diagram. Okay, as you can see this in figure, there is a total volume is indicated by capital V. In your left side you can see that capital V is indicated. Okay, uh, volume of air is indicated by VA, volume of water is indicated by VW, and volume of solid is indicated by VS. Okay, now at the right hand side you can see that weight of this section is indicated by capital V. Now this capital V is weight of a total. Now this weight contains weight of air, weight of water, and weight of solids. Okay, now if we want to find the total volume, what will we need to do is we need to add the volume of solids, volume of water, and volume of air. Okay, so as I have shown in this, total volume is indicated by V is equal to volume of air plus volume of water plus volume of solids. Now volume of air is indicated by VA, volume of water is indicated by VW, and volume of solid is indicated by VS. Same to same. If we want to find the total weight of solids, it will be indicated by WA, WW, and WS. As we know that air particles have no weight. Okay, so WA, weight of air, will be always 0. So total weight will be addition of weight of water plus weight of solids. Okay, so this is the equation of three phase diagram. Okay, if you guys have any query you can ask me in comment section. Okay, so two phase diagram, our next topic is two phase diagram. Now why two phase diagram is required? See, when we are analyzing the three phase diagram, it becomes difficult for us uh, to find the what is the exact amount of air present, what is the exact amount of water present in that soil. Okay, so for making easy analysis, we have uh, derived this in two ways. Either soil will be fully saturated, or either soil will be fully dry soil. See, one third situation is available where soil is partially saturated and partially dry. Okay, but it is not included in this lecture. Now when soil is completely dry, okay, so it is what will happen when soil is completely dry? You can see in this figure. When soil is completely dry, so there is no portion of air available in this portion. Sorry, there is no portion of water available because it is a dry. So due to dry situation of soil, there is no portion of water available in that soil. So it will we can neglect this situation. We can neglect this content. So that will be in the, two phase. One is solid and one is air for fully dry soil. Same to same, when we are going to discuss about the fully saturated soil, there is no presence of air in that soil, so there is also two phase. One is solids and one is water. We are going to discuss about this in this lecture. See, as I have already said, when the soil is completely dry, there is no water, and when the soil is fully saturated, there is no air. Okay, two phase diagram for fully saturated soil. Now first of all, see this figure. Hmm. If you are comparing three phase diagram with this, you can see this in this figure there is no presence of air. Okay, so if air is not present, we can neglect the volume of air. Okay, so for fully saturated soils, you can see this. For fully saturated soils, total total volume is Va plus Vw plus Vs. That is volume of air plus volume of water plus volume of solids. But we know that for fully saturated soil, volume of air is equal to 0. So total volume is summation of volume of water plus volume of solids. Same to same, total weight of a soil. Now total weight W is equal to WA plus WW plus WS. We already know that weight of air is always 0, so total weight will be sum of a weight of water plus weight of solids. Okay, if you guys want to note down this, you can note down this. Also this is included in your books. Now two phase diagram for fully dry soil. First of all, try to understand the figure. Okay, see, for fully dry soil there is no presence of water, so here only two phases are available, one is solids and one is air. So now for fully dry soil, water is always 0, so total volume is the sum of volume of solids plus volume of air. Now total volume will be volume of solid, that is Vs, and volume of air is Va, and total weight, that is W. Now W is equal to weight of air plus weight of soil solids. Now weight of air, that is Wa, plus weight of solid, that is Ws. So W will be Wa plus Ws, but we know that air has a no weight, so Wa will be 0. So total weight is equal to sum of weight of solids. So W is equal to Ws. This is the final equation of two phase diagram for fully dry, for fully dry soils. Okay, so this is the end of our lecture. We will discuss more topics in our next lecture. If you guys have any comment, if you guys have any queries, you can ask in our comment sections. Thank you.